All right, we are back. So this is right where we left off yesterday. We were at the problem 6, and this should be right where we stopped. So we had written our system, which is honestly probably the hardest part. You know, if people say, I'm pretty good at the word problems, I just have a hard time setting them up. That to me, all I hear is, I'm pretty good at driving. I just have a hard time not running people over. Like, understand what you're saying, because the entire essence of word problems is step 2. Step 1 is easy. Step 3, we just practiced and took a quiz on. It's step 2. So if you find yourself struggling with step 2, don't look at it as just a minor thing. That is everything, right? Is the ability to take words and write equations. So make sure you let me know. Keep me in the loop if that's what the hard part is for you. All right, so let's get to it. As I said when we left off yesterday, this one is not particularly well suited for either method. And that's kind of why I thought it was a perfect place to stop. So could you make a case for substitution? I a million percent would say yes. I look at that bottom equation and I think to myself, if I would just add that 3s across to the other side, I'd have myself L equals and I could make a box and I'm off. Could you make a case for elimination?
Yeah.
I again would vote yes. And so what I wanted to talk to you about, and I didn't want to try to fit it in the last minute and a half of class, is everyone is going to feel different ways. Some of you walked away from the last quiz liking substitution better, and some of you walked away liking elimination better. I don't know what the split is. But let's say that I like elimination better. That's me. Okay. So what I'm going to do, this is my personal choice, is I'm going to take the 2L and I'm going to subtract it over here to be with his buddy. Now, if I do that, if I take away 2L's from the already 1L that's there, how many L's will I have? I'll have negative 1L, and then I can copy down the plus S equals negative 6. And just like that, what looked to be a messy situation is actually now a very non-messy situation. So if you're someone who likes elimination better, this problem really works well for you because not only does it just take one move to set it up so that all the stuff is on the same side, like in the right place is what I should say, but not only that, but when you get there, why is this such a lovely system now? It's a what? It's a level 1. Good for you. Like I look at this system now and I say, this system is auto eliminating. I don't have to do anything now except add them together because it's just how convenient. And I'm making no hint or indication that this would normally happen. But if it does, you're like, well, thank you, math gods. Like, I appreciate the gift. So if I went this route and I chose elimination, I could just add these equations together. And when I add them together, the L's cancel just like that. What do I have left? Negative 2S's equals, and if I divide both sides by negative 2, I just figured out that S is 9. And notice what the question says. It says, what is the smaller number? By my math, I believe that means that we're done, correct? So I could stop at this point. I don't have to do any more math. Just say the smaller number is 9, and I'm out. I don't want to move on and act like substitution was not also a viable option. As you'll see in what I'm about to write, it's not as good as this, but I don't want you to walk away from it thinking like, oh, so I have to do it that way. Of course you don't have to do it that way. We haven't done a single problem in the last yesterday and today so far that has to be done a certain way. Anything I like substitution for, you could be stubborn and turn it into elimination. Like it's going to work if you know what you're doing. So if you like what just happened and you don't want to write anything else down other than, of course, the answer, the sentence, I wouldn't blame you, but just follow along with what I'm about to do and just you can give me your 2 cents. So here it goes. Going back to this system, the one in the big red bubble, I could, if I wanted to, take this minus 3s and move it to the other side. You would agree? And if I do that, then I get L equals positive 3s minus 12. Everybody okay? And then I did one step and now I'm set up for substitution, you see. And now where would I put that box?
In your S.
in place of the L, but I would make sure to put it in the top equation. And then that top equation would simply say where L used to be, it would now say 3S minus 12, and then plus S equals 2L minus 6. Do you see the problem with this? Do you see what I did wrong that's going to make this not work, Josh? Correct. There were two L's, and what I should have done is put them together beforehand, right? So what I should have done is taken this 2L across, because if you have L's in multiple locations and you substitute, you got to substitute into both of them. So you could do it, like I said, you could put the L's together first, or I could have not been a knucklehead. And over on this right-hand side, I'm going to circle something in green right now. This L, I hope you can see that, also needed to be swapped out, right? We've never seen a double substitution before, but you got to put it in both places. So in both L's, I need to put it. So I'm going to have 2 times where L used to be minus 6. And again, where L used to be, I have to put another 3S minus 12. There's zero chance that you're sitting here right now saying, yeah, I like this way better, right? And so what you're going to learn as you go is that you're going to find with some problems there's a path of least resistance. Could we finish this problem?
Yeah.
Absolutely. Do we want to?
No.
Probably not. Could we? I mean, yeah, we did. This is what I quizzed you on in August and September was combine like terms, distribute, move stuff around. You could solve that equation. I have infinite faith in you. And guess what the answer will be? S equals 9. Still going to be 9. Like it ain't going to change just because we did it a different way. It's just going to suck a lot more. So that's all I have to say about problem 6. So I'm a huge fan of elimination, FYI. So when I'm given a choice and it looks like it's going to be like close one or the other, I'm picking elimination like probably 10 times out of 10 personally. I like it better. All right, let's head to problem 7 so I can get this done and we can have some work time. What are our variables going to be on problem 7? I think N and C make perfect sense. So let's let C equal what?
Cash. Or candy.
How many what were sold? I like that. Thank you. So let C equal number of candy bars sold. Thank you, by the way, for being thoughtful enough to say that. A lot of times people will, because we're used to saying how much does a candy bar cost? And then I have to yell at people because I'm like, it's in the problem, bro. Right? Like, bless you. Like we know candy bars cost $1.75 each. So thank you for thinking that through. So C is not the cost, but rather the number of candy bars that Stu sold. And what's our other variable? I believe you said N? Number of nachos sold. Very good. I'm gonna pause this real quick. All right, we got our variables declared, and now it's time to write a system. People struggle with this system sometimes because I think what's tough about this is that it's blended. And what I mean by that is there's not any one sentence that gives you an equation. You have to make the equations sort of hybrid. So there's information in the first sentence that applies to both equations, and there's information in the second sentence. I don't know. You know what I'm trying to say, maybe. I don't know. Anyone want to take a shot at an equation? Jeff?
1.75C plus 2.5 N equals 86.5.
I agree with this one. I like this equation. So if I sell $1.75 times the number of candy bars plus 250 times the number of nachos, I know that however much money I made on candy and nachos, if I add them together, makes 86.50. Nice job on that one. I don't usually put the zeros after the 5. Like if it's 50 cents, I put it when I'm typing up the problem because no one goes to the store and says like, hey, how much did that cost you? Oh, it was $2.5. Like we say 250, but in the math that we're doing, I usually take off ending zeros because they're just weird. It's up to you. What's the other equation?
You could do. No.
This is always the stopping point because there's no one equation that just explicitly says this is a fact. It's there and it's implied. But you've got to crack the code. I'm guessing I'm going to give it a minute and see if anyone else grabs it. Nope, you're overanalyzing this. I just need to find one more relationship between C and N. That's what equations they're relationships. How do two variables play off each other and relate to each other? There's one more thing in this problem that is a fact.
40C.
Say what? You're gonna that's I can't write that as an equation. They equal to 40. That's the one. Good job. And I know again that you probably had that quick, and that's the equation that sort of hides from us. It's in plain sight, but it's hard to see because I don't explicitly at any point in the problem say the number of candy plus the number of nachos equals 40. We have to infer that from being good at the English language that, oh, Stu sold a total of 40 items. 40 candy bars and nachos. I don't know how many of each he sold, but that's kind of the whole point of this problem. So great job cracking that code to a bunch of you there. So we don't know how many candy bars he sold. We don't know how many orders of nachos he sold. We just know that together he sold 40 items. So that type of problem has always been a bit of a struggle just because that one equation hides. So good so far. I'm going to use elimination because I like it better. And that's so if you don't want to, I would recommend that you just, tune me out for the next couple of minutes. If I want to use elimination, I need to make something cancel out. So I'm going to take the bottom equation and multiply everything by negative 1.75. So I don't need a calculator for the first couple of distributions. Like I just know that this one is negative 1.75C. And I know that this one is minus 1.75N. But what we generally like to use our calculators for is these decimal operations. And so I'm going to type into my calculator 1.75 times 40. All right. And my calculator says it's 70. So I, of course, am going to outsmart my calculator and put negative 70. As I've said many times, I don't usually type negatives into calculators. I just know what it's going to be and then let the calculator do the annoying part. So at this point now, I'm going to copy the top equation back down. I don't like to add two equations together that aren't right above or below each other. So I normally do this off to the side, but I didn't have much room over here. So that's why I'm doing it this way. So what we have now is this system right here. We created one of the equations and the other one was already kind of existing before. So let's do it. Let's add a line and let's get to adding these equations together. Elimination is still elimination. Even if you have to use decimals, like that's who cares, right? Let's add them together. How many C's do we get? None. Good. That's the whole point. What's negative $1.75 plus 250? I don't think so. If you owe me $1.75, but you give me 250, how much would I give you back? 75 cents. Remember, you owe me $1.75. You owe me $1.75. You pay me 250. You cover your debt, but you covered it by 75 cents too much. If what I'm saying doesn't make any sense, it's fine. You just type negative 1.75 plus 2.5 in your calculator and you'll be good to go. No worries at all. And then I got to do a little bit more. Probably don't need our calculators, but again, I don't care. So what's negative 70 plus 86 and a half? Of course it is. Good job. And so I wanted to make sure you understand that sometimes we have to venture into the forest of decimals, and it's okay. So I'm going to take 16.5 and I'm going to divide it by my 0.75 and I'm going to get 22. What does that mean? In the context of this problem, what does that number represent?
22 nachos.
Stu sold 22 orders of nachos. Correct. And then I would look at the problem. And if it happens to say how many orders of nachos did Stu sell, then I'd be done. But it doesn't. It says how many of each item did Stu sell. So I'm kind of like, grown. I'll go find the other one. And how am I going to find the other one? Yeah, 40 minus 22. You already know that Stu sold 40 things. And based on the information we have, he just sells nachos and candy bars. So like if he sold 40 total and 22 were this kind, the other 18 have to be the other kind. So he obviously sold 18 candy bars. So again, you would just write a sentence and say, Stu sold 18 candy bars and 22 orders of nachos. When I wrote this problem the other day, I was going to just put nachos, and then I knew someone would probably bring up some conversation that would take 11 silly minutes of people wondering, does he sell them by the individual nacho chip? And so I just wanted to avoid it by putting order of nachos. So just saved us all a little misery there. Got it? Do you have any questions? Because if you're not, I've got an assignment all ready to roll for you. I just worked through all 8 of them on the assignment. They're all good. They all have nice answers, which is nice. I'm going to pause the recording. I will leave it alive and well, but I will hit the pause. And then any questions that you have, as always, I will add them to the recording.